Hello everyone, welcome to this short video tutorial on circuit diagram or wiring of Arduino robots. And don't be confused using the word robot, okay? I use the word robot because a robot is any autonomous system that exists in the physical world. Or, it can sense its environment and then take certain actions based on the inputs it received. So that's why I use the word robot. So it could be an Arduino project, a system, but as far as it can sense the environment and take certain actions on its own, it's a robot. Now Arduino consists of both physical programmable circuit boards, often referred to as microcontrollers, and a piece of software or IDE, which is known as the integrated development environment, that can run on your computer, used to write and upload computer codes to the physical board. To implement any Arduino project, this is very important to start with the circuit design, which serve as a guide for connecting other components to the system. Now, to design a circuit diagram for a particular Arduino robot or Arduino application or Arduino project, you could use the following. We have so many of them, but I'll be discussing just three, and then I'll be laying more emphasis on one, which we'll be using in our subsequent projects. The first one here is we have what we call the Tinkercad platform by Autodesk. Tinkercad is a free, easy-to-use web app that equips the next generation of designers and engineers with the fundamental skills for innovation, 3D design, electronics, and coding. It offers Arduino and other boards novice an easy way to design the circuit with breadboard, where sensors, actuators, and also write the program using block and text format. You can simulate the circuit and check how the peripherals would interact. Now, the next one is the Purchase software by Lab Center Electronics. Purchase Design Suite is an offline simulator for a printed circuit board design as PCB software. In Protest, you can simulate the circuit with advanced support of libraries and a ton of components required for designing the circuit. You can directly write a .hex file to the Arduino and also other microcontrollers. Now, the third one I want to briefly explain is the Fritzing. We have the Fritzing tool. The Fritzing is a great open source tool for anyone to learn, share, and prototype their electronic projects. It allows you to design a schematic and thus a part which can then be added to very professional looking wiring diagrams. You can even design your own PCBs and have them fabricated from the file you design. However, the circuit cannot be simulated on the Fritzing. That's one disadvantage of the Fritzing. However, I just have one project here, simple design I made for an intruder detection system. I designed. From this simple circuit diagram, you can see it's designed using the Fritzing software. Now you can see that the Fritzing typically has on the menu you have the file, the edit, the parts, the view, windows, routing, help, and then the rest. And also by the sides towards the the extreme right, you can see we have parts, we have core, we have mine, and the rest of them. The core component is what is displayed. Mine are those components you either imported from other places into the Fritzing. That's one thing it has. For example, in this project, I imported SIM 800. I also imported the bulb. I also imported the PR motion sensor and yeah, yeah, yeah. I think, oh yes, including the relay module too, is not part of the initial package of the Fritzing. So I had to import them. So you will see them under mines. Now, in this simple circuit, you can see that we have a breadboard, we have the Arduino Uno. These are components, the PIR motion sensor, the buzzer, the bulb, the relay module, the AC power source, SIM 800. Now, on the breadboard, you discover that two wires were connected from the Arduino directly to the breadboard. The red and the black. You see that the red from 5 volt was connected to a rail, close the red rail, and then the one coming from the GND, which is ground, that's the black cable, was connected to the to the blue rail. That signifies negative, which is 0 volts, and then the red for 5 volts. Now other components taps their powers from these two, and then from the SIM 800 you can see connection to pin 3 and yes, pin 3 and then the pin 2. And also you can see from the PIR motion sensor the connections to the Arduino, to the digital pins, and then you also see the relay module where we tap the ground voltage and then the 5 volts, and then the signals also run to pin 13 on the Arduino. Now this is simply the circuit diagram. Following this, I can just implement my system. So that's how important this circuit design is. So before you implement any project, the first thing to do is, you identify the required component. After identifying the required component, you now do what? You now design the circuit. Give us the circuit wiring of what you intend. Once that is done, this can just be simply implemented and then run. Thank you for listening and remain blessed.